Hello students, myself Ashish Chawla. Today we discuss about the volume of cube and cuboid. First we take about cuboid. This is the shape of a cuboid having length L, breadth B and height h. The volume of cuboid is defined as area of base into height. As see here, the base of the cuboid is nothing but a rectangle. This is the base of a cuboid which is in the shape of a rectangle having length L and breadth B. So the area of base is L into B and its height is h. So the volume of the cuboid is L into B into h. So this is the formula for the volume of a cuboid. Now we discuss about the volume of cube. In cube we know that all the sides are of the same length. Cube is nothing but a cuboid in which length, breadth and height all are of the same dimension. Length is also of a units, breadth is also a unit and height is also of a unit. Length is equals to breadth is equals to height, let's say it be a. The side of a cube is a. So the volume is defined as, according we apply the same formula for the cuboid, that is L into B into H. Now we put in place of L I put A, in place of B I again put A, in place of H I put again A. So the volume of the cube is A into A into A, that is A cube. So this is the formula for the volume of cube and cuboid. Now we start with the problems. Now the first problem, the volume, find the volume cube having total surface area of 150 centimeter square. We have to find the volume of a cube whose total surface area is 150 centimeter square. So the solid that is given to us is cube, and the side of the cube, that is A, which is, let it be A, and its surface area, total surface area is given to us, that is 6A square, which is equals to 150 centimeter square, that is given to us. Now at 6A square is equals to 150. Now solving this equation, we get A square is equals to 150 divided by 6, that is equals to 25. So as A square is equals to 25, so the value of A is 5, or we can say the side of a cube is of 5 centimeter. Now in this question we have to find the volume of the cube. We know that the volume of cube is defined as side cube, and side we already found, that is A equals to 5. So put A equals to 5 here, 5 cube, and we know that 5 cube is nothing but 125 centimeter cubic. So the volume of cube is 125 centimeter cubic. Now let's do one more problem. The area of adjacent faces of cuboid are x, y, z square unit. The area of the adjacent faces of a cuboid are x, y, z square unit. Then show that the volume is equals to under root of x into y into z. In this question, we have given a cuboid. Let's first draw the cuboid. Let's say this is a cuboid, and in the question it is given that the area of the adjacent faces are x, y, and z. So let's say the area of this face, let's say the area of this face is x, and the area of this face is y, and the area of this face is z square units. Let us assume that the length of the cuboid is L, breadth of the cuboid is B, and the height of the cuboid is h. So here x is the area of this face. This face is nothing but a rectangle having length L and height h. So its area is x. We can say x is equals to L into h. L into h. Same way, this face having an area y square units, and this is in the shape of a rectangle having breadth b and height h. So its area is b into h. So the value of y is equals to b into h. Now the z is the area of this surface, and this is again in the form of a rectangle having length L and breadth b, having length L and breadth b. So z is equals to L into b. This is the equation number 1, equation number 2, this is equation number 3. Now when we are multiplying these three equations, 1 multiplied by 2 multiplied by 3, what we get? We're getting x, y, z on the left hand side. And on the right hand side, what we observe, the length is coming 2 times, breadth is coming 2 times, and the height is coming 2 times. So all are get squared, L square, B square, or H square. So x, y, z is equals to L, B, H the whole square. It can be written like this: x, y, z is equals to L into B into H the whole square. So LBH is nothing but the volume of a cuboid, we know that. So x, y, z is equals to V square. So volume of a cuboid is equals to, when you shift the square to that side, so it gets under root. So V is equals to under root of x, y, z. That is, the volume of a cuboid is under root of x, y, z. That we have to prove it. So this is a one required result. Now we move to the next problem. How many bricks will be required? How many bricks will be required to construct a wall 13.5 meter long, 6 meter high, and 22.5 centimeter thick? If each brick measures 27 centimeter into 12.5 centimeter into 9 centimeter. So in this question we have to find how many bricks are required to construct a wall which is 13.5 meter long, 6 meter high, and 22.5 centimeter thick. If we construct the wall with the help of bricks, and the bricks dimensions are given to us, that is this one. Now with the help of this bricks you have to construct a wall. Let's draw the picture of it. That can be easily understood then. Let's say first of all we draw a wall. It is given that the wall is 13.5 meter long. This is the wall, 13.5 meter long, and it is 6 meter high. Let's say this is 6 meter high wall, and it is only 22.5 centimeter thick. See the unit carefully, that is 22.5 centimeter. So this is nothing but the length of a cuboid, this is nothing but the breadth of the cuboid, and this is nothing but the height of the cuboid. This is our wall. Now we have to create this wall with the help of a brick, and the dimension of the bricks are given to us. The dimensions of the bricks are given to us. Let's say this is a brick. So its dimension are given to us. Its length is 27 centimeter. That is our L. Its breadth is 12.5 centimeter and its height is 9 centimeter. Now with the help of this brick we have to construct this wall. So we have to find how many such bricks are required. Let me suppose that n bricks are required to construct this wall. So this wall is constructed with the help of these bricks, n bricks. So their volumes must be equal. So the volume of this brick is nothing but L into B into H, and the volume of this wall is nothing but capital L into capital B into capital H. So we have to equate their volumes. So n times the volume of brick, that is small l small b h, is equals to capital L capital B capital H. So number of bricks is equals to capital L capital B capital H divided by small l small b small h. Now what we see here, the some units are in meter and some units are in centimeter. Now we have to convert all the units in, let's say, centimeter. So on the upside, that is length is 13.5 meter, so we have to convert into centimeter. So we have to multiply it by 100. Now breadth is in centimeter, so there is no need to convert. The height is 6 meter, so we have to multiply with 100 to convert it into centimeter. Now it is divided by the length, the volume of the brick. The volume of the brick, all the units of the bricks are in centimeter, so there is no need to convert it. So 27 into 12.5 into 9. Now we have to remove the decimals. Now first we remove this decimal. We have to put 1 0 at the downside. We remove this decimal. We have to put one more 0 at the downside, and the denominator side we remove this decimal. We have to put one more 0 on the upside. Now we cancel all the zeros. Now what we see here, this 225 and 125 are get cancelled with 25. Now we have to cancel it with 25. 225 divided by 25 we get 9. 125 divided by 25 we get 5. 9 and 9 are get cancelled, and 5 120 times. Now 135 and 27 are get cancelled with, let's say, 9. 9 3 is 27, and 135 it is cancelled with 1 5 15 times, and 15 is cancelled with 3 5 times. So what is our answer? So 5 into 20, that is 100. 100 into 6, that is 600. Now 600 in 10, that is 6000. So the number of bricks that is required to construct the wall is 6000. You do need 6000 bricks to construct the wall. So that is our answer. Now we move to the next question. Now we have three metal cubes. Three metal cubes whose edge measures 3, 4, 5 centimeter respectively are melted to form a single cube. Find the side of the new cube formed. Now let's see the solution of this. So in this question we have three cubes. The first cube is of dimension 3, and another cube is of dimension 4, and we have another cube of dimension 5. all these three cubes are melted to form a single cube. Let's say this is a big cube that is formed by melting these three cubes. Let's say the side of this cube is A. That the side of this cube is A. Now, when we melt, or when we are converting one thing into another by melting, the volumes remain the same. So the volume of all these three cubes should be equal to the volume of this cube. And the formula for the volume of cube, we know that is the volume of cube is side cube. So 3 cube, the volume of this cube, the volume of this cube is 4 cube, the volume of this cube is 5 cube. So we have to add these volumes. Now the volume of all these three cubes is equals to the volume of this big cube, that is A cube. 3 cube, we know that it is 27, 4 cube, that is 64, 5 cube, that is 125. That should be equals to A cube. Now 27 plus 64 plus 125, what we are getting? 216 A cube. And we know that the cube of 6 is 216. So the value of A is 6. Or we can say the side of the new cube is 6 centimeter. So this is our answer. The side of the new cube is 6 centimeter. Now we move to the next problem. A cube of side 9 centimeter is immersed completely into the rectangular tank containing water if the dimension of the base are 15 centimeter and 12 centimeter, 15 centimeter and 12 centimeter, then find the rise in water level. So in this question, what we have given to us, we have given a cube of side 9 centimeter. Let's say this is a cube of side 9 centimeter. The side of the cube is 9 centimeter is given to us, and we have a rectangular tank that is in the shape of a cuboid. Rectangular tank is nothing but a cuboid. Let's say draw a cuboid. This is a cuboid, and whose base are given to us. The dimension of the base are given to us, that is 15 centimeter and 12 centimeter. So its length is 15 centimeter and the breadth is 12 centimeter. Now there is some water in it. Let's say up to this height there is a water inside it. That's the initial height of the water is h. This is the length, this is breadth. Now this is the initial height of a water level in the tank. Now when we immerse this cube, when we are immersing this cube into this water, what will happen? When we are immersing this cube in this water, due to immersing of this cube in this water, the water level get increased. Let's say the water level is up to this position. Let's say that this is the increase in the water level due to the immersing of the cube. So let's denote it by h dash. This is the increase in the water level due to the immersing of the cube in the rectangular tank. Now what we see here, this portion is created due to the immersing of this cube. So we can say that the volume of the cube is equals to the volume of this portion of a cuboid, because this portion is created due to the volume of this cube. So the volume of the cube should be equals to the volume of this portion. So this portion is nothing but a cuboid having length 15 breadth, that is same as 12, and height is h dash, that is increase in the level. So now we put the values. The volume of cube, that is a cube, that is 9 cube, should be equals to 15 into 12 into h dash. So h dash is equals to 9 cube divided by 15 into 12. So 9 cube is equals to 9 into 9 into 9, 15 into 12. Now we cancel with 3 5 times. Again we cancel with 3 4 times. So 9 into 9, that is 81 divided by 20, or you can say when 81 is divided by 20 we get 4.05 centimeters. So the increase in the water level in the rectangular tank is by 4.05 centimeters. Now we move to the next question. A plot of land in the form of a rectangle. A plot of land in the form of rectangle has a dimension 40 into 20 meter. 40 meter by 20 meter. A square bit of dimension 5 meter by 5 meter is dug 10 meter deep, and earth taken out from it is spread evenly on the rectangular field, on the rectangular field. Find the height, or you can say the increase in the level of rectangular field. Increase in level of rectangular field. So let's start with the solution. Now in this question, first of all, what we are given to us, we are given a rectangular field. Let's draw the rectangular field. This is our rectangular field. Its dimension are given to us, that is length is given to us, that is 40 meter, and the breadth is given to us, that is 20 meter. Now on this rectangular field, what we have to do, one more thing is given to us, that is a square pit. Let's draw a square pit. This is a square pit of dimension 5 meter. We have given a square pit of dimension 5 meter. Now this pit is dug 10 meter deep. We dug this 10 meter deep. Now we dug it 10 meter deep. Now whatever the earth is taken out from this pit, the earth which is taken out from this pit, this is the earth. Now this earth which is taken out from it is spread onto this field. We have to spread this pit, we have to spread this earth taken out from this pit on this rectangular field. Now first of all we have to find how much amount of earth is taken out from this pit. That is nothing but the volume of pit. Volume of pit gives us the volume of earth taken out, and the pit is nothing but a cuboid having length 5, breadth 5, and the height we can say 10. So 5 into 5 into 10 meter cubic. So that this much amount of earth is taken out from this pit. Now this earth is spread evenly on the rectangular plot. Now when we are spreading this sand or the earth on this rectangular plot, the level of the rectangular plot get increased. Let's say the level of the rectangular plot is increased by height h. We don't know how much it increases. Let's assume that it will increase by h. So we have to find the height or the increase in the level of the rectangular plot. So this increase in level is created due to the sand which is taken out from this pit. So we can say that the volume of this cuboid, this is nothing but a cuboid again, length 40, breadth 20 and height h that we have to find. This cuboid is created due to this pit, the sand of this pit. So we have to equate that volumes. So we can say that volume of this rectangular plot is 40 into 20 into h meter cubic. So these two volumes should be equal. So the 5 into 5 into 10 should be equals to 40 into 20 into h. So the value of h is equals to 5 into 5 into 10 divided by 40 into 20 meter, because all the units are in meter. Now cancel all the terms which can be cancelled. 0 and 0 are get cancelled. 5 8 times. Now what we are remaining? We remain with 5 divided by 16 meter. So that much amount of height is raised due to the pit. So this is our answer, 5 by 16 meter. Now we do the next question. The next question is a river 40 meter wide and 20 meter deep is flowing at the rate 3 kilometer per hour. Find the amount of water flow. Find the amount of water flow in 5 minutes. So in this question, what we are given? We are given a river which is 40 meter wide and 20 meter deep. We have given a river which is 40 meter wide, and 20 meter deep. Let's say this is 40 meter wide and this is 20 meter deep. We are drawing the cross section part of a river. This is a river. This is a cross section of a river which is 40 meter wide and 20 meter wide. This is nothing but the cross section of a river. Let's say this is a river, the river which is flowing. Now the river is flowing at the rate of 3 kilometer per hour. That is the speed. Speed is given to us, that is 3 kilometer per hour. Now we have to find how much amount of water is flow within 5 minutes. As the river is flowing at the rate of 3 kilometer per hour, so the distance covered by this cross section part of a river in 5 minutes is given as we know that the distance is equals to speed into time. Speed we know that is 3 kilometer per hour, and the time we know that is 5 minutes. So the distance traveled by this cross section during the 5 minutes is given as distance that is traveled by this cross section is equals to speed into time. So the speed is 3 kilometer per hour, but the time is in minutes, so we have to convert this into hour. So we can write time as 5 by 60 hours. So much kilometers it will travel in 5 minutes. So 15, that is 1/4 of kilometer. 3 into 5, that is 15, and 15 and 60 are get cancelled 4 times. So 1 by 4 kilometers. So the distance traveled by, or we can say 1 by 4 kilometer, or you can say 1 by 4 into 1000 meter. That is equals to 250 meter. So the distance traveled by this cross section is 250 meter in 5 seconds. After 5 minutes, this cross section will come at this position. Clear? So this distance is nothing but 250 meter. So much amount of water is flowed during the 5 minutes through this river. So this is nothing but again a cuboid having length 250, breadth 40 and height 20. So the amount of water flow through this river through river in 5 minutes is equals to, that is length 250, breadth 40, and height 20. All are in meters, so the volume is in meter cubic. So the answer is 25 into 4, that is 100, 100 into 2, 200. So 3 zeros are 1, 2, 3 meter cubic. So much meter cubic of water is flowed, that is 2 lakhs. 2 lakh meter cubic of water is flowed. Thank you.